Welcome Algebra 1 students, this is Miss Parsons. Make sure you have your notebook ready. Today we're talking about applications of slope-intercept form. So we're going to talk about some real-world situations of where we would use slope-intercept form. So remember that slope-intercept form is y equals mx plus b. So we need two things. We need the slope, which is our m, and we need our y-intercept, which is our b, to be able to write an equation. So our b is going to be like our starting amount. So in this situation, suppose that a bike rents for $12 plus $1.50 per hour, and we want to find a way to model this using all combinations of hours and money spent algebraically. So our y-intercept is what it's going to cost us regardless of whether we rent this bike for 1 hour or we rent it for 100 hours. It is going to cost us $12. Okay, and our slope is going to be what changes. So in this case, our amount changes $1.50 per hour because that is what it's going to cost us per hour to rent. So our equation is y equals $1.50x plus 12. So what is our y? What is this equation calculating? Well, our y is going to represent our total cost based on our x value, which is the number of hours that we are renting the bike. So can we use an equation to figure out the cost if we rented it for 5 hours? So 5 is going to be our x because it's talking about the total number of hours, and we want to know our total cost, which is our y. So if I put that into my equation, 150 times 5 plus the $12 it's going to cost us regardless, and it's going to cost us $19.50. Now, what if I said, hey, I only have $20 to spend? That means I'm restricting my total cost to be $20, but I want to know how many hours it's going to cost us. So I can plug in 20 for y in my equation. And I want to know what x is, so I have a two-step equation I have to solve. So I'm going to minus 12 from both sides. Gives me 8 equals $1.50 times x. And I have to divide by 150. So x is going to be 5.3, meaning I can rent this bike for 5.3 hours with my $20. So then maybe I want to represent this and model this a different way. So I can use tables or graphs to also model this situation. So I have the same situation with the bike, $1.50 per hour plus the $12. Now keep in mind that x was the number of hours that we were renting this bike. So I can only start it at 0 and go up because you cannot have negative hours. And then remember that your y represents your total cost. So if I rented this bike for 0 hours, it would cost me $12. For 1 hour, it would cost me $13.50. And for 2 hours, it would cost me $15. So a chart could be very helpful if you just wanted to look at the chart and say, okay, how much is it going to cost me for 1 hour? And I can go in the chart and look very quickly. Also, the graph. If I rented it for 0 hours, it's going to cost me $12. I can use this table over here. For 1 hour, it's going to be about $13.50. And of course, why would these dots stay? Because that would just make life too easy. And for 2 hours, it would cost me about $15. And we know that it is going to be a linear equation because that is what y equals mx plus b is. We know that the slope is going to be positive because as the more time we rent it for, the cost is going to go up. So if we can identify the slope and the y-intercept of any situation, we can write an equation that represents it. So in this case, I'm just going to give you the slope and the y-intercept. So remember, your slope is m, your y-intercept is b, and I'm going to put it into the equation y equals mx plus b. So I'm going to substitute these numbers for m and b. So y equals, instead of m, I'm going to put 2x plus a fourth, y equals 2/3 x plus 5, and y equals negative 4x plus 0. Now the plus 0 is kind of overkill here. We know if we add 0 to it, nothing's going to happen. So it is more appropriate to write just negative 4x. So to be able to write a linear equation, we need to identify the slope, which is m, and the y-intercept, which is b. The intercept in most real-world applications is going to be like your starting amount, or maybe a one-time fee. So we've seen those. The starting amount, maybe if you work off commission, maybe you get $500 and 20% commission. So your starting amount's $500. You see one-time fees a lot, especially like at gyms. They have a one-time fee and it's $20 per month. Planet Fitness does it, LA Fitness does it. So you'll see those a lot in the real world as well. Your slope is your rate of change. So this could be like your speed. Maybe you're going 60 miles per hour. It can also be the cost over time, right? With the bike, we were charged $1.50 per hour. So you're going to be looking for keywords like per and each and every. Those are key indicators that is talking about your slope. So I have another situation here where it costs $32 to run a medium-sized car plus 25 cents for each mile driven over 150 miles. So basically you're getting 150 miles free without being charged that 25 cents. So can we write an equation? So let's see, can you identify your slope? Well, I have this key word here, each. So that is a dead giveaway that this has to be our slope. So our slope is 25 cents for every mile over 150. Our y-intercepts, so what is our starting amount? Well, that is $32. Okay, I'm getting charged $32 if I decide not to even drive this thing off the parking lot. They are still going to charge me $32. So in my equation, y equals mx plus b, y is going to be my total cost. How much it's going to cost me to rent this car, and x is going to be the miles over 150. So can we use this to calculate how much it would cost to drive 300 miles? So I need to find my x, which is the miles over 150. So I need to find out how many miles 300 is over 150. Well, that is a simple subtraction problem, 150. So x is going to be 150 miles, but I want to know my total cost. So I'm going to put this into my equation. Well, what is my equation? I was able to identify my slope. I was able to identify my intercept. So my y is y equals 0.25x plus 32. Once you're able to identify that slope and intercept, it is super easy. So now I'm going to plug in 150 to be my x and calculate this out. So how much is it going to cost me to drive 300 miles? I'm going to take 0.25 times 150 plus 32, and it's going to cost me $69.50. Okay, what if I said, hey, I only have $100. How far can I drive? So I know my total cost is going to be $100, but I want to find out how many miles I can drive over 150. Okay, so I'm going to plug in 100 for my y. I want to know how many miles. So I now have a two-step equation. I'm going to minus 32 from both sides, and I get 68 equals 0.25 times x. Divide by 0.25, and I can drive 272 miles over 150. So really, if I added those together, because I got 150 miles without being charged, I can actually drive 422 miles for $100. So maybe I wanted to represent this with a table or a graph. So remember that x is your miles over 150. So it doesn't make sense to have negative miles. Okay, you cannot drive negative miles. Even if you put that car in reverse and drove it all the way to Florida, your odometer would not go backwards. Okay, you are still racking up miles in that car. So I'm going to start with 0 miles over 150, so that's 150 miles. 50 miles over 150, so really you're driving 200 miles. And 100 miles over 150, so really you're driving 250 miles. And I can put this, sorry, this is supposed to be x, into my equation. So to drive 0 miles, really 150 miles, it's going to cost you $32. To drive 50 miles over 150, so 200 miles total, it's going to cost you $44.50. And to drive 100 miles over 150, so 250 miles, it's going to cost you $57. So if I wanted to make my graph 20, 30, 40, 50, 60, okay, remember your y is your total cost, 10, 20, 30, 40, 50, 60, 80, 90, 100. Okay, and remember that your x is miles over 150. And I can use this chart to graph. So if I drove 0 miles, it's going to cost me $32. To drive 50 miles, it's going to cost me $44.50. So right about here. And then 100 miles. Oh, technology. 100 miles, it's going to cost me 57. So right about here. And we know it's going to be linear because it's y equals mx plus b. We know that it is going to be positive because the more miles you drive, the more it is going to cost. Okay, so that is how we represent some real world situations in slope-intercept form. So knowing that all you need to know is your slope and your intercept, you can write an equation, you can represent it with a table, and you can represent it with a graph.